Some important carbon compounds. Ethanol is an ingredient of all alcoholic beverages such as wine, beer, and whiskey. The invention of wine sometime must have happened by pure accident. Skinned grapes are reacted with yeast containing enzymes. When the fruit is crushed, the enzymes come into contact with the glucose containing juice and catalyze the reaction of glucose fermentation. The process produces ethyl alcohol and carbon dioxide. Alcoholic beverages produced in the past, such as beer and wine, had low alcohol content. Beverages with high alcohol content, such as vodka or cognac, are products of modern times and have been obtained using more advanced chemical technology. Ethanol is the second member of the homologous series of alcohols, the first member being methanol. The formula of ethanol is C2H5OH. Ethanol is the most important of all alcohols and is commonly known as ethyl alcohol. The black balls here represent the carbon atoms. The red ball the oxygen atom, and the white ball is of the hydrogen atom. OH as a whole represents the hydroxyl group. It can also be written as the line diagram shown on the screen in two-dimensional view. Few other names of ethanol are ethyl alcohol, pure alcohol, hydroxyethane, drinking alcohol, ethyl hydrate, absolute alcohol. Physical properties of ethanol. Ethanol is a colorless liquid having unpleasant smell and a burning taste. Ethanol is a volatile liquid having a low boiling point of 78 degrees centigrade. That is 351 Kelvin. It is lighter than water. Ethanol mixes with water in any proportion. The solubility of ethanol in water is due to the presence of hydroxyl group in it. Ethanol containing 5% water is called rectified spirit. Rectified spirit is a commercial alcohol. 100% pure ethanol is called absolute alcohol. Ethanol is a covalent compound. Ethanol does not contain any hydrogen ions, so it is a neutral compound. Thus, ethanol has no effect on any litmus solution. In fact, all the alcohols are neutral compounds and hence have no effect on litmus. Intoxicating beverages contain ethanol in different proportions. Beer and wine contain up to 10% ethanol. Whiskey, rum contain 40% of it by volume. Chemical properties of ethanol. Let us first learn about combustion reaction. Ethanol is a highly inflammable liquid. It catches fire easily and starts burning. Ethanol burns readily in air with blue flame to form carbon dioxide and water vapor and releases lot of heat and light. Reaction with sodium metal. Sodium metal test. When a small piece of sodium metal is dropped into alcohol, free from moisture, hydrogen is liberated. This is accompanied by effervescence. Sodium ethoxide is also formed. Test for alcohols. We take a freshly cut small piece of sodium metal in a perfectly dry test tube containing 1 to 2 ml of pure ethanol. Bubbles of hydrogen gas start coming out. Collect the hydrogen gas by keeping an inverted empty test tube. Now bring a lighted matchstick near the mouth of the test tube in which the gas is collected. It catches fire with a popping sound. This is a characteristic of hydrogen gas. Sodium ethoxide is also formed during the reaction. Presence of hydrogen gas is the test for ethanol. Oxidation reactions. Oxidation means controlled combustion. When ethanol is heated with alkaline potassium permanganate solution or acidified potassium dichromate solution, it gets oxidized to ethanoic acid. This reaction can be carried out by adding 5% aqueous solution of potassium permanganate in the sodium hydroxide solution to ethanol dropwise till the purple color of potassium permanganate solution no longer disappears. On warming the test tube containing ethanol and alkaline potassium permanganate solution gently in hot water bath, ethanol is oxidized to ethanoic acid. Thus, ethanoic acid is formed by the oxidation of ethanol by using a strong oxidizing agent. This ethanoic acid or acetic acid formed by the oxidation of ethanol can turn blue litmus paper red. We can also carry out the reaction of oxidation of ethanol to ethanoic acid by using acidified potassium dichromate as an oxidizing agent. The conversion of ethanol into ethanoic acid is called an oxidation reaction because oxygen is added to it during this conversion. In fact, all the alcohols can be oxidized to the corresponding carboxylic acids by strong oxidizing agents. Dehydration of ethanol to form unsaturated hydrocarbon. Dehydration of an alcohol means removal of water molecule from it. When ethanol is heated with excess of concentrated sulfuric acid at 170 degrees centigrade, that is 443 Kelvin, it gets dehydrated to form ethene, which is an unsaturated hydrocarbon. During dehydration of ethanol molecule, H from the CH3 group and OH from the CH2OH group are removed in the form of a water molecule, resulting in the formation of ethene molecule, that is CH2 double bond CH2. In this reaction, concentrated sulfuric acid acts as a dehydrating agent which removes water from the ethanol molecule. Esterification reaction. ethanol reacts with ethanoic acid in the presence of a little concentrated sulfuric acid to form an ester: ethyl, ethanoate and water. Ethyl ethanoate has a fruity odor. This is called esterification reaction. The product formed is an ester. All esters are sweet-smelling and used for making perfumes. Concentrated sulfuric acid acts as a catalyst for the esterification. This reaction is used as a test for alcohols as well as for carboxylic acids. Esterification reactions are reversible, and to make them go in the forward direction, concentrated sulfuric acid is added in small quantities as it is a dehydrating agent. It helps in the forward esterification by removing water formed, thereby preventing reverse reaction. We take 2 to 3 ml of ethanol and 2 to 3 ml of ethanoic acid in a dry test tube. To this mixture, carefully add a drop of concentrated acid. Next, we warm the test tube in hot water bath for 4 to 5 minutes. A sweet, fruity smell of ester, ethyl ethanoate, comes out of the tube. This activity is carried out to identify alcohols from carboxylic acids. Saponification reaction. Reverse of esterification reaction is saponification reaction. It is a process in which an ester is hydrolyzed in the presence of a strong base like sodium hydroxide to form alcohol and carboxylic acid. On heating ethyl ethanoate with sodium hydroxide solution, its fruity smell disappears. The carboxylic acid is obtained as sodium salt because of the presence of sodium hydroxide. We take about 2 to 3 ml of ethyl ethanoate in a test tube and add 4 to 5 ml of sodium hydroxide solution to it. The ester ethyl ethanoate is immiscible in water and forms a separate layer. In the test tube, we can observe 2 separate layers. The upper layer is of ester and the lower layer is of sodium hydroxide solution. Warm the test tube in a water bath at room temperature around 330 Kelvin, shaking the tube occasionally. After 5 to 10 minutes of warming and shaking, the upper layer starts disappearing gradually. This is because the ester is getting converted into ethanol and sodium salt of ethanoic acid, both soluble in water. The saponification process takes about 15 to 20 minutes. Uses of ethanol. Ethyl alcohol. Ethyl alcohol is used in the manufacture of paints, varnishes, lacquers, medicines, perfumes, dyes, soaps and synthetic rubber. Ethyl alcohol is used as a solvent. Many organic compounds which are insoluble in water are soluble in ethyl alcohol. Being a good solvent, ethyl alcohol is used in medicines such as tincture iodine, cough syrups and many tonics. Ethyl alcohol ethanol is used as a fuel in cars along with petrol. It is also used as a fuel in spirit lamps. Ethyl alcohol is used in alcoholic drinks that are beverages like whiskey, wine, beer and other liquors. Whiskey contains about 35% of ethyl alcohol. Wine contains 10% to 20% of ethyl alcohol. Harmful effects of drinking alcohol. We should not consume any alcoholic drinks because alcohol slows down the activity of the nervous system and the brain, due to which the judgment of a person is impaired and his reaction becomes slow. So, a person driving a car under the influence of alcohol cannot judge a situation properly and acts quickly in case of an emergency. In this way, drunken driving leads to increased road accidents. Heavy drinking of alcohol over a long period of time can damage the stomach, liver, heart and even brain. The liver disease known as cirrhosis caused by alcohol can lead to death. The drinking of adulterated alcohol containing methyl alcohol causes severe poisoning, leading to blindness and even death. Ethanol as a stimulant. The case of methanol. When taken internally, methanol is a poison. So unlike ethanol, drinking methanol, even in a very small quantity, can cause severe poisoning, leading to blindness and even death. This happens as follows. Methanol damages the optic nerve, causing permanent blindness in a person. Methanol is oxidized to methanol in the liver. Methanol reacts rapidly with the components of cells, causing coagulation of their protoplasm. Due to this, the cells stop functioning normally. This leads to the death of the person who drinks methanol. Denatured alcohol or denatured ethanol. A lot of ethyl alcohol, that is ethanol, is used in industry for manufacturing various products. For industry purposes, ethyl alcohol is supplied duty-free, that is without charging production tax by the government. This makes the industrial alcohol much cheaper than its market rate. To prevent the misuse of industrial alcohol for drinking purpose or black marketing, ethyl alcohol meant for industrial purposes is denatured by adding small amounts of poisonous substances like methanol, pyridine or copper sulfate, etc. The addition of these poisonous substances makes the ethyl alcohol unfit for drinking. We can now say that denatured alcohol is ethyl alcohol which has been made unfit for drinking purpose by adding small amounts of poisonous substances like methanol, pyridine, copper sulfate, etc. Addition of small amount of copper sulfate imparts a blue color to industrial ethyl alcohol so that it can be easily identified. Ethanoic acid, acetic acid and its properties. The molecular formula of ethanoic acid is CH3COOH. Ethanoic acid is commonly called acetic acid and belongs to a group of acids called carboxylic acids. 5 to 8% solution of acetic acid in water is called vinegar and is used widely as a preservative in pickles. The melting point of pure ethanoic acid is 290 Kelvin and hence it often freezes during winter. This gave its name glacial acetic acid. The group of organic compounds called carboxylic acids are obviously characterized by their acidity. However, unlike mineral acids like HCl, which are completely ionized, carboxylic acids are weak acids. Physical properties. Ethanoic acid is a colorless liquid with sour taste and smell of vinegar. It is miscible with water in all proportions. Chemical properties. The chemical properties of carboxyl group acid are mainly because of COOH group. Acidic nature. Ethanoic acid or glacial acetic acid is acidic in nature. The acidic nature can be tested by dipping a blue litmus strip in a tube containing acetic acid. It changes to red. Ethanoic acid and other organic acids are weaker acids than the mineral acids like HCl, HNO3 and H2SO4, which are also inorganic acids. Ethanoic acids and other organic acids are weakly dissociated acids while hydrochloric acids and other inorganic acids are almost completely dissociated acids. Reaction with metals. Ethanoic acid evolves hydrogen on reacting with active metals present above hydrogen in the reactivity series. As a result, metal salts are formed. Ethanoic acid reacts with sodium to form sodium ethanoate and hydrogen. Ethanoic acid reacts with calcium to form calcium ethanoate and hydrogen. Neutralization reactions. Like mineral acids, ethanoic acid reacts with a base such as sodium hydroxide to give a salt, sodium ethanoate, or commonly called sodium acetate, and water. In a test tube, we take a small amount of solid sodium hydrogen carbonate. To it, we add a few drops of ethanoic acid. A chemical reaction takes place. A gas with brisk effervescence is evolved. When the vapors are passed through lime water, it becomes milky. This shows that the gas evolved in the reaction is carbon dioxide. Esterification reaction. Esters are most commonly formed by reaction of an acid and an alcohol. Ethanoic acid reacts with absolute ethanol in the presence of an acid catalyst to give an ester. Esters are sweet-smelling substances. These are used in making perfumes and as flavoring agents. Esters react in the presence of an acid or a base to give back the alcohol and carboxylic acid. This reaction is known as saponification because it is used in the preparation of soaps. We take 1 ml ethanol or absolute alcohol and 1 ml glacial acetic acid along with a few drops of concentrated sulfuric acid in a test tube. We next warm it in a water bath for at least 5 minutes. We then pour contents into a beaker containing 20 to 50 ml of water. Pleasant smell is experienced, which shows that ethyl acetate is formed in the reaction. This is called ester hydrolysis. Uses of ethanoic acid. A 5 to 8% solution of ethanoic acid in aqueous solution is known as vinegar. Vinegar is used in pickles, noodles, sauces, salads as a preservative to provide a typical flavor. It is used for the preparation of cellulose acetate for making waterproof fabrics. It is used in the preparation for white lead, that is 2Pb, CO3, Pb, OH whole twice, pigment. Lead metal is dissolved in dilute ethanoic acid and then CO2 gas is passed in it.